Hey guys, we got a special guest here. We have JJ from ASUS. And as we mentioned a couple weeks ago, we were going to sit down, go through. ASUS was really great and brought everything they make. So we have tons of Z77 boards here. We're actually going to be able to give some away. We've got a couple of tablets, brand new monitor we saw at CES. So there's a bunch of stuff to talk about. But the focus here is obviously, today is Ivy Bridge. And with that, you've got all the motherboard partners. And here we've got Intel Z77 chipset. We've got one example of it here, and we're going to go through, like I said, the majority of ASUS's product stack. So JJ, welcome. First thing, can you just kind of tell me what your product stack is? I know there are a bunch of motherboards that you have here. There are even more that are on the market right now. Tell me what you've got, right? Explain all of them. And first of all, how many are we looking at? What is your entirety of the Z77 stack?
In regards to our core stack, we're looking at 9 SKUs.
So first, define what is core stack to you guys?
That's kind of, let's say, the stack that the majority of our users are interested in when they're going out there and they're actually going to a brick and mortar store. They're going to actually online to Newegg. What boards they're looking at? So this is going to be standard, pro, deluxe.
So standard is at the bottom.
Correct. That's our entry level kind of value SKU, and then from there we move up. We do have some other more price conscientious SKUs for users that are looking for something a little bit more standard and fair, but that's kind of our entry level point. We work our way up.
So standard, what price point does that start at?
We're targeting a little bit over $200, so MSRP should about $205.
Okay. And then, so from standard, you've got how many above standard?
That's going to go 8 additional boards.
Okay. And then where does the top one top at it, price-wise?
Top end is actually going to be our premium board and also our formula board. So that's going to be on the ROG side, and then high end for what's referred to as our channel lineup. Both those boards, though, aren't part of the initial core launch. Okay. So the pricing hasn't been set, but expect price points over $300.
Okay, gotcha. Now your core stack there, and this is something you guys have done for like the past couple of years here. You've kind of focused on a common feature set that all of these boards have.
Yes, definitely.
What is that? What do you get regardless of which model you pick?
That's a really good point. I think that going back, even actually if we go all the way back to P55, that's kind of been one of the underlying focus points for us, is to kind of have non-negotiables that are present across a large set of boards. So for this generation, we've pretty much built on what we've laid the groundwork for in X79, Z68, P67, and even boards before that. So we've got, of course, classic things which you would come to expect by now, which is like Uefi, right? We've got Uefi and everything. Digital power delivery is also another big proponent for us. It's on every active chipset. It's going to be the same thing. It's going to be improved upon this generation, but we keep it present.
Now, how do you, so those two you just mentioned, Uefi, how has that changed since?
I think even for when we first implemented, right, it's not necessarily about changing it just to change something, right? Our big focus is about making sure that the usability and the functionality is first and foremost met. After that, it's a question of where can we make improvements in terms of the usability that we get from feedback from users on. And so for this generation, we've had a couple of small, very small minor items that I think add a little bit more usability to it, but no big apparent changes. Okay.
So one thing I saw when I was a big fan of Uefi when that first hit and your first kind of interfaces. What I would like to see though is kind of a more significant departure from hey, this is a traditional BIOS interface, but it looks better, and you've got mouse control as well, to something a little more revolutionary, right? Where it's something that's truly built around a GUI and truly built around user interaction via mouse. Is that, why haven't we seen that yet? And is that in the cards for the future?
Most 100%. I mean, we've spent a huge amount of work. Even when we first originally incorporated Uefi, I think over 50% of our actual BIOS R&D was committed to actually doing that across the chipset level. For us and the amount of workers that we have on the BIOS R&D, that's a very big investment. But more so, really what it comes down to is a question of compatibility and infrastructure. We can't necessarily just change everything up without keeping in mind that we still need to make sure that this is usable for all the peripherals. Stuff, like keyboards and mice, which, we had pre-existing code base that worked for years and years and years, has to be reconsidered all over again. So all those little things have to be accounted for before we can go into make bigger changes. But definitely bigger changes are in the works in terms of continuing forward with what we've laid the groundwork for, and I think make it something really cool, really exciting, really visceral in terms of functionality and the usability that you have there.
Yeah, I mean, again, I would just like to see something that's more than, you know, this is just a kind of a fresh layer of paint over, and a more usable version of what we've had for so long. What kind of time frame do you think we'd see for more dramatic changes? Is it something you'd see this generation or a generation or two out?
Well, I mean, you've got a lot of restrictions, right? I mean, with upcoming operating systems like Windows 8, there's adjustments to the ROM sizes in terms of the compliance that you have to work with there. We always have to make sure that there's enough space for incremental updates that come down the road, microcode that changes, things like that. So a lot of that stuff has to be factored, but I think time frame probably realistically is going to be somewhere probably between 16 to 24 months.
Okay.
And if it's going to happen, definitely, like always, I think probably ROG is going to lead the way.
Okay.
Because we've got more flexibility to be on the bleeding edge with those boards.
I gotcha. Cool. Yeah. Okay, so you got UEFI. Power delivery, you said, has been enhanced a little bit this generation. Yeah. What have you done differently?
We've changed it up. So when we first started, right, we started with a CPU VRM-centric digital power delivery and control. Then we evolved into adding DRAM. Okay. And now for this generation is iGPU. So pretty much everything on the top side of the board is going to be entirely covered by power control and delivery.
Okay, and what does that mean? Like, what does that give an end user?
Right. It's about understanding the context to it. And contextually, what it's really giving you is control parameters. So we're opening up the types of control options that you have to make adjustments to any one of those key parameters. And the key point is that since it's a digital design, we can accurately do that within both the operating system level, and we can do it within, of course, the UEFI tables. And what that means to users is going to be things like low-line calibration. You're going to be able to modify and adjust that real time. You're going to be able to make adjustments, say, to the thermal control parameters of the VRM assembly. If you want to go ahead and assign different junction points for the temperature response, you can make adjustments to that. So a lot of really deep level stuff is in there. We've got auto rules, of course, to automatically adjust that for users that don't have an understanding of that.
Yeah.
But that's the type of stuff that you're going to have with digital power control.
Now, and a lot of this obviously plays into overclocking.
I think in some ways, there's definitely controls that we've introduced, just like some of our TPU and EPU controls that also cut down into efficiency.
Okay.
For this generation, we actually have a new set of controls that ties into the digital power delivery called Smart Digi Plus. That we can actually have packaged target profiles. So if you want to have the CPU worked at a fixed 45 watts or like 35 watts, you can go ahead and click that, and we'll automatically make all the adjustments to target down on those profiles for you.
Interesting.
So it's not just overclocking related. It's really, for us, I think we feel about giving you flexibility at how you want to define the system and giving you the controls for that.
So that's kind of like almost like a configurable TDP, but for the desktop. Yeah, so you can kind of roll your own SKUs if you wanted to.
Yeah, very, very similar to that.
And what points do you offer?
Those are the two specific points in terms of 45 watts and then 35 watts.
Okay.
Then from there, of course, there are more granular options that you have within the EPU interface.
Okay.
If you want to set specific V-core reductions, and then other adjustments you can go around and play around with if you don't want to work within those targeted profiles that we have.
So the targeted 45 and 35 watt profiles, I'm assuming that those are also undervolting?
That's correct.
Okay.
Yeah.
And you're undervolting by amount that you've predetermined to be safe for the vast majority of chips out there?
Yeah, in terms of the overall binning process, at a minimum level, it's usually somewhere between about 200, 250 CPUs. On the top end, sometimes it can be over 400 CPUs.
Okay.
And that goes through multiple steppings, through different types of environments. So we do try to take a really large level look at that. Even though it's a preset, and ideally we wouldn't want to work always from preset-based data.
Yeah.
We try to pull up a large enough base of information so that we're going to have good, reliable results.
Okay. Yeah. Cool. And so far, both of these changes, the targeted TDPs and stuff like that, that's across everything standard and above.
Yep, correct.
Okay. So continue. What else do we do this generation?
Yeah. Outside of course, the digital VRM designs, we're also introducing in an extension to USB3 Boost. So for a couple of generations now, we've been messaging extending USB3 functionality. So moving away from the bot limited protocol interface mode and being able to go ahead and shift into either a SCSI protocol mode or UASP operation mode.
Yeah.
So that's been pretty cool. And for Intel, one of the unique characteristics, right, for this chipset is we have native USB3 support. Mm-hmm. So we're actually also able to now extend that USB3 Boost to the chipset USB3 controllers. And
what devices do you see USB3 Boost supporting or actually giving you tangible results with?
The most common devices are going to be storage-based devices. Mm-hmm. Definitely where you're going to see the performance increase. And relative to the device, of course, you're going to see varying levels. But it doesn't necessarily also have to be a USB 3 device. Mm-hmm. You can actually have USB 2 flash storage devices like thumb drives that can actually also get an operational improvement in terms of bandwidth.
But do you see that? Are there USB 3 storage devices on the market today that do show a performance increase due to USB 3 Boost?
Oh yeah, definitely.
Okay.
Yeah.
And are there particular ones, or is it?
For one that say, for example, that we brought here is Thermaltake has just updated their Black X enclosure to actually be fully compliant with the UASB protocol.
Okay.
So that's one that you could go ahead and then take any of your 3.5 inch or 2.5 inch storage devices, drop it in there, and get that benefit.
Now, when they did that update, is that a USB 3 controller update, or is it a firmware update, or a combination of the two?
Yes, combination of the two. So for one, you actually have to have the controller chip be UASB compliant.
Okay.
Then secondary to that, there does have to be firmware on top of that. So even if you did have, let's say, a 1051E ASMedia controller chip for that,
okay,
you still would have to have the UASB firmware on there.
Got it.
That's the same thing for the corresponding controller that we're using on the board level.
And what kind of a performance boost do you see with that enabled?
Really depends, of course, on the device that you're utilizing, right?
Yeah.
So just like you talked about in Thunderbolt, right? The faster storage device you have, the bigger performance gains you can see from the interconnect.
Yeah.
So in that same type of configuration, if we look at top end improvement, you can definitely see over 150 megabytes increase in performance.
Okay.
Yeah. So it's very tangible. I mean, and you talk about backups. You talk about working from an actual disk. You're going to see tangible benefits.
Okay. All right, continue. So you've got native USB 3. Obviously, that's a feature of the 7 Series chipset. Mm-hmm. What else do you have that's common here across the product
Another
line?
really big one has fan control functionality. So for multiple generations, we've really been trying to harp on that the usability within the fan control systems, especially from other vendors, has been subpar. Mm-hmm. So we've really been pushing it in terms of extending it from just being like one controller to multiple controllers. So X79, we stepped up to pretty much every board having 6 fan headers, with all of them having a manual fan control option.
Okay. And these are individual ICs on the board that control these?
That's all controlled by the Super I/O controller, and then feeding into that.
Okay.
So for this generation, we've extended it further. We're still essentially keeping the same maximum number of headers and controllable, but we added 3-pin support for chassis fans.
Okay.
And then in addition to that, we have a full automatic fan calibration process. So this is really cool because normally when you work off of preset data, all right, you don't necessarily know what are the minimum and maximum values of the fan. So as an example, if I set silent within my fan protocol option, it's not actually silent. It's a guesstimate, right? We're saying maybe 800 to like 1,000 RPM is what we approximate to be silent.
Yeah.
But what we can actually do now is we'll ramp it all the way to 100%. We'll go all the way down to the minimum rotation speed, and we'll know what the effective cutoff point is. And so then you go ahead and click silent. When you click that, it actually will turn off all the fans.
Okay.
And it'll have the CPU fans operating at their minimum value. So we actually are able to have full fan control functionality that's based off of real data that's specific to your system and your configuration.
So what you're doing there is you're varying voltage to figure out when the fan actually stops. Versus otherwise you would just guess at what that minimum voltage would be.
Correct. Yeah. Okay. And that's all logged. So we pass all that information per each header. It's stored by the Super I/O controller and stored in the algorithm and software. And there's some other really cool parameters, like we can actually assign the position of the header, because not all users are always going to maybe connect one header in the right place, right?
Yeah.
So what happens if you put your CPU fan header on chassis 1?
Yeah.
Normally you'd have to know that, right?
Yeah, because you'd get an error in the past, right? If you pick the wrong one, you get the CPU fan not connected error.
So you can go now into actually our software interface, and you can relabel the headers. So if you want to call like chassis 1 Corsair H100, right? You could label it that.
Okay.
And you could set independent fan options. So if you want to have one be a preset, the other one be a fixed fan profile, and the other one be on a fan curve, that's all entirely customizable.
Okay, very cool.
Yeah, so that's another unique option that, once again, where we talk about that kind of core value board having that level of control, I think, especially in comparison to other top-end competitors' boards, it's not even close. So that's a pretty cool option. So as I noted, one of the big things that we've continually focused on is improving the quality of the network controllers that we've been phasing onto boards.
Okay.
And so for a couple of generations now, we've been really pushing on incorporating the Intel native gigabit controller. And so we've been.
And is this so? All your boards have 2 NICs?
No. So starting once again from the standard SKU all the way up, every single board least features one single NIC, and if that NIC is there, it's going to be the Intel NIC.
Okay. And where do you get? What is the cutoff for 2 NICs? Like, what's the?
Where we start off, if we're incorporating a dual NIC design, is going to be on the Deluxe and then on the Premium, as well as the WS.
Okay.
With the Deluxe, you get one Intel and you get one Realtek.
Okay.
The WS, we put actually 2 of the L series, so the server grade Intel NICs. And then on the Premium, you have 2 of the Intel NICs as well.
Okay. All right. Gotcha. So sorry. Continue.
No worries. So for this generation, we wanted to extend a little bit further, give you a little bit more customization and control. So we're adding packet priority control software. So you'll have an interface within our AI Suite 2 software package where you can essentially see any network-centric service. So you could pop open up your browser, downloading management client, whatever it might be, and you can go ahead and prioritize the value for that. So if you're doing more gaming, then you can prioritize Steam. If you're doing maybe more browsing, prioritize Internet Explorer, whatever it might be.
So it's just software-directed QoS, basically.
Yeah.
Now, is this
It's easy to understand because I think for a lot of networking, there's a lot of users that don't understand a lot of the complex aspects behind networking.
And this obviously, is this only on the Intel NICs or on your boards that have one Intel, one Realtek? Do you also have?
It would actually also work on the Deluxe board that has the Realtek and the Intel NIC, but it is limited to currently only the physical network controllers. So we, as we'll talk about, we've had some boards that are also now implementing Wi-Fi, but we don't have that functionality on there.
Okay. Any other changes on the wired Ethernet side?
No, that's the main focus there.
Okay, so you mentioned Wi-Fi. One push that Intel has with Ivy Bridge and the 7 series is to bring wireless display wide-eye to desktops. How are you implementing that? And if you don't know, basically you use the QuickSync transcode engine to basically encode the current frame buffer, what you're displaying on the screen, send it over Wi-Fi to a box that's basically an H.264 decoder, and you can display that in 1080p. And it's a way of wirelessly getting what you see on your desktop, over to a TV. Now, obviously, there's latency associated with that, so you don't get. It's not real time. It's not what you'd want to play a first person like a Twitch FPS on, but it's good enough for video, for web browsing, so on and so forth.
Yeah, extended display as well works really well with it as well.
Yeah, very true. So tell me about wide-eye. Do any of your boards have support for it? Are they coming bundled with it?
We've taken a little bit of a different approach just because with wide-eye adoption, it's still kind of in its infancy in terms of a lot of receivers being out there and different clients.
Yeah, there's still only 3 1080p receivers out there, I think, right now.
Correct. And so with that, we still do want to support it. So actually our ROG boards actually have this little special adapter that will come with them. So it's a little combo adapter that lets you use either any mini PCIe device or any mSATA device. So if a user wanted to go ahead and put like a 6230N on there, they could go ahead and do that and equip it to be wide-eye capable.
And where does that device go on the board? So there's a header that device goes into?
It mounts directly onto the back plane and the I/O section of the board. So for some of those boards will have that capability, but for our core stack, which is representative of the standard, the Pro, the Deluxe, and the Premium, they will inherently come integrated with actually Wi-Fi implemented. And that's not based on an Intel wireless controller, but we're adding a lot of additional functionality to go ahead and give you more than just internet connectivity. So as part of that, it's our Wi-Fi Go package suite.
Well, so hold on real quick. So standard and above, these all have integrated Wi-Fi?
That's correct.
But you can't do wide-eye with those.
That's correct, because as you know, the requisite requires integrated graphics, right, from Intel chipset, and then the Intel wireless controller.
Okay. And then this, real quick, this combo solution here, are you sharing one PCIe across these two when you switch between them?
They actually have their own dedicated, so you can actually use both devices simultaneously.
And so then this is effectively what, like a by 2 PCIe that's branching off the PCH?
Correct, yeah, that's all linked up on the board, but both are fully independent of each other, so you can go ahead and utilize the full Wi-Fi functionality. So 6230N would provide you dual band and BT, and then from there on the other end, you could of course have the operating system running off of your mSATA. Like this is a 120 gigabyte, run core drive, so you have a lot of flexibility with that little device. Okay,
very cool. All right, so continue. So you got Wi-Fi Go. Tell me what that is.
Yeah, with Wi-Fi Go, there's definitely a lot of functions that we've added in, and most of it centers around usability. We want to try to make it more practical to take advantage of the Wi-Fi implementation. So one of them is going to be that we have DLNA media serving functionality. So any type of DLNA client, we can stream out video, music, or photos to that system. This is different than just receiving, right? Because on the receiving end, anything that pops up on a local network through a DLNA router would be able to see it. We can actually stream out and send and control it, not only from within the interface in that AI Suite 2 program, but if you had like a tablet, like a Transformer Prime, or even like an iPad, we have an application to support that as well. There's also some other cool functionality, like we can do right-click send to, where we can send files, as well as remote desktop functionality, as well as some other stuff too.
Okay, and you're going to show that working right here. So tell us a bit about the display that this is hooked up to. This is what you saw, what you guys announced at CES.
Yeah, this is our upcoming QHD panel, so 2560 by 1440 IPS display. So this is a high resolution, really focused on the guys that want high quality display, but big real estate.
Okay. And availability on this display?
We're hoping to have it right now sometime between the July to August timeframe.
Okay.
There'll be 2 variants. There's going to be a PA series, so part of our Pro Art, and then there'll be the standard VA series.
Okay. And differences between the two?
It's going to be factory calibration as well as the special quick fit options that are going to be more focused for content professionals.
Okay. And which one gets what?
PA series gets the calibration and the quick fit settings.
Okay. Any idea about price range yet?
Right now we haven't hammered it down, but definitely expect to be aggressive in regards to other QHD panels that are on the market.
Okay. Very cool. And so that's one end of what we're seeing right now. And on the other end, you've got the new TF300.
Yes. Mm-hmm.
And so take me through this demo. What's happening here? What are we looking at?
So it's pretty straightforward in terms of how we have it set up. We have right now our premium board with the Wi-Fi Go controller set up. And then this is dual band supported, but we're actually doing this off of 2.4 gigahertz.
Okay.
So essentially all of these are just on the same network. And on this desktop system, we essentially have our media files. So we're going to just go ahead and click on this video file, and we're going to select a receiver. This receiver could be a television, it could be this transformer, or it could be any number of other devices.
Okay.
So once we click that, we're just going to go ahead and click the play button, and then it will initiate and start on that other device, and we're streaming it over. And you can go ahead and control and stop it via these on-screen menus.
Okay. And so what's being streamed over there, we still need decode support for it on the tablet itself? Or?
That's correct.
Okay.
Yeah. And so that's going to be codec dependent. So right now we're utilizing some of the underlying technology within Windows 7. So we've got Windows Media Player 7 here opened up. And if you have any codec that's in there, then you're good to go.
Okay. But on the receiving device, do you need codec support, or is it just getting effectively a frame dump here?
Yes, it's essentially receiving a frame dump.
Okay.
Yeah.
Very cool. Okay, so that takes care of networking. What else do you have in 7 Series?
On 7 Series, one of the really cool features that we introduced on top-end boards, like a lot of what we're bringing over on the series, is a really cool one's called USB BIOS flashback.
Okay.
So this is an easy way to either update the UEFI or to go ahead and recover a corrupted ROM.
Okay.
So all you have to do is essentially take a flash drive, you plug it into a USB port on the back.
Okay. Any USB port?
No, it's just going to be a specific port because it's actually hardware-centric. But no CPU, no memory, no graphics card is required. Actually, all you would need to have is just PSU standby power connected to the board.
Okay.
And that will allow you to actually directly on a low level update the board. This can also, like I said, work from a recovery standpoint that maybe, let's say, you corrupt the ROM from overclocking.
Yeah.
Maybe you have like a PCIe compatibility issue with your graphics card doesn't post.
Yeah.
How would you flash it if we even did release an update? Normally you'd be stuck.
Yeah.
But here we can go ahead and just do it directly.
So you don't need CPU. You don't need memory either.
Yep,
you don't need
no
any
graphics.
graphics.
Just standby power. That's all that's required.
What if I screw up the BIOS flash? Like if I pull the plug in the middle of a BIOS flash, ROM's obviously corrupt. Can this still recover it?
Yes. In most situations, generally it's going to be able to re-overwrite the actual corrupted ROM and get the board back up and running.
And so what's the actual process here? I take the USB image. I'm assuming I just dump your image in the root.
It's a specific, exactly. You just take the ROM file. It has to be in a specific format in terms of the naming scheme.
Okay.
Once you go ahead and do that, you just plug it in. You hold the button down. There's an LED that's on the BIOS flashback button. Once you go ahead and click that down, it takes about 30 seconds to a minute, depending on the size of the ROM update.
Yeah.
And you're good to go.
Awesome. And what's the visual feedback to let me know that it's done?
There's a blinking LED that's on the button, so once it actually finishes blinking, it lets you know that the ROM process is completed.
Very cool. Okay, and you didn't have this before. This is.
No, it's actually something that we started off on our high-end boards with ROG. Okay. And then we trickled down.
Okay.
And as part of this core lineup, once again, starting from standard all the way up the chain, every single board has it.
Very
so
cool.
It really kind of hits that once again that we feel that they're non-negotiables that we want to have on every.
No, that's a really cool feature. Okay, what else? What else do you have?
We've gone ahead and also done some updating to the audio package support. So based on feedback of users, we had a lot of people that told us DTS Sensation was not something that they were really using a lot. And so we've upgraded to DTS Ultra 2 PC, which gives us DTS Connect. So we have the ability to do the multi-channel encoding through the actual codec package. So that's a nice update as well.
So multi-channel encoding, and what do you get that sends out?
That would send out through the digital connection that's on the board.
Okay.
So you can go ahead and send that out to like a receiver or a digital set of speakers.
So for any system sounds then?
That's correct, yeah.
That's similar to what I guess the first Enforce used to do, right?
Yeah, exactly. But it used actually Dolby Digital Live.
Yeah.
And the main differential between the DTS package and the current actually Dolby Digital Live is the compression ratio and the bitrate encoding.
Okay.
It's 4 times higher on the DTS package.
Okay.
So we essentially can give you a much better compression level in terms of not affecting the sound as much.
And how do you enable this? Like, how do I take advantage of this?
It's just a simple access in the control menu interface for the DTS package. So it's just right click on audio properties and you're good to go.
Okay, and then that'll kind of encode all of my sounds and put them out as a what does the receiver see?
It would see a DTS 5.1.
Okay, very cool.
Or 7.1. Either one.
And a lot of this stuff, it's interesting. We don't get enough time to really, because we've got to review like dozens of motherboards at launch. You could write 20 pages on all the stuff that you guys put in here.
Yeah, sure.
Right? Like it's kind of cool that we're able to kind of go through all of this because back in the day there was the big concern that when the CPU started, when integration happened and the CPU started including more and more, that motherboards would kind of lose their importance.
You had to worry about commoditizing the motherboard, I think,
absolutely.
to a degree.
And to an extent that's happened, but you guys are really kind of focused on fit and finish and making all of the stuff that like you said, the non-negotiables that kind of make the overall package very 100%.
Nice. Yeah, I mean, I think our perspective really is that we want to break away from the perception of it being about spec to spec.
Yeah.
Right? I mean, if you look at one board to another board, they both might have 4 fan headers, right? They might have 5 fan headers, but what's the actual experience and the usability that you get between the two, right? Or we know that every current board on the market essentially has Uefi, but is the experience the same?
Yeah.
It's not. When you talk about the response, the fluidity of it, even things like compatibility, right? The IMC might play a large part in terms of the memory divider and the frequency support that's potentially capable on the platform, but there's still a huge amount of work that we have to do from a tuning level, right? To make sure that it works with higher density DIMMs. You have CPU validation support that has to be put into play. So a lot of that stuff still falls upon the motherboard vendor. And that's even outside of, like you said, the fit and finish and the +1 feature points that make the board, that much more fun to work with and build.
Cool. Well, we asked you guys for a bunch of questions, and I want to get to those next. And we'll also talk about some of the things like Thunderbolt. I know that's been on a lot of your minds, and you guys have some stuff to talk about with Thunderbolt as well. So let's get to that.
Yeah.
So one of the first questions that a lot of folks asked, they want to know about Thunderbolt support. Obviously, this was, Thunderbolt's a standard that Intel and Apple kind of co-introduced last year. And the promise was that it's going to be coming for PCs. It'll be coming for PCs. And with Ivy Bridge, we finally get it. So what is ASUS's Thunderbolt strategy and what products do we see it on? How do we get it?
Yeah, definitely. We're 100% committed to making sure that interconnect is supported on our boards. So we're going to actually have it be present on 2 different ways.
Okay.
One is we're going to have the majority of our lineup. So this includes a lot of what we already discussed, like the standard, Pro, Deluxe, Tough. Those boards, they'll all have like a TB header. This TB header will be located like usually somewhere like in the bottom area of the board, usually like in proximity to the front USB ports.
Okay.
And that header will then essentially allow you to make a connection to a Thunderbolt add-in card.
Okay.
The Thunderbolt add-in card will plug into a by-4 interconnect PCIe slot on the board, and then that will go ahead and actually give you a Thunderbolt connectivity on the board. So that way you don't necessarily have to pay for the expense of it being integrated directly on the board, but you get the flexibility of being able to upgrade it if you want it.
So then what is the TB header used for? Is that to provide PCIe connectivity, or is that...
for the link for the display port output functionality.
Okay. Gotcha.
So that's what that's functionality for. In terms of a secondary option, we're also going to have 2 SKUs that will be coming to the market that will have it directly integrated in the back I/O.
Okay, so what's available today won't be those 2 SKUs though, right?
Correct. Those will be coming a little bit after the initial launch.
Okay.
But we will have, by the end of this month, the actual boards as well as the card finalized. In terms of time frame for release, probably be a little bit after that, but we're finalizing really right now all the validation.
Any idea on pricing for the card?
Yes, we're expecting approximate pricing to be about $40 for the add-in card. So
that's not bad at all. That's awesome. Okay. And just to clarify, so standard and above, you'll have some form of Thunderbolt.
Correct. Actually, even on some of our entry-level SKUs like the LE will even have the TB header. So we're very committed to making sure that you have that expansion option available to you.
And what are you doing validation-wise? Like, can, Apple has a Thunderbolt display out. Are you guys testing with that? Is it going to work with that?
Yeah, most definitely. We're working with all the different partners that are out there, whether they're storage manufacturers, display panel manufacturers, all the different types of interconnects. So we're working with Intel and their team, working with Apple as well, and we're working on our own internal level to do validation as well. So in all those stages, we're checking functionality.
Cool. Another, kind of group of questions surrounded around T-Top, which is your new memory technology that you've kind of baked into your boards.
Yeah, to a degree. It's a new design approach in terms of the trace layout. It's actually sponsored by Intel in terms of it being white paper guidance.
Okay.
So
now explain, because not everyone designs motherboards, right? So what is white paper guidance from a motherboard manufacturer's perspective?
So for all the chipsets that get developed and the architectural kind of initiatives that Intel comes to market with, is that they do approach us as a board vendor and say, you know what, these are the kind of design implementations that we recommend that you execute to try to at least get the minimum level or hopefully the best level of performance from the board.
Now, and are these just like discrete features that they're listing, or are they actual like layout guidelines?
They're actually layout guidelines.
Okay. So it's kind of like if we were to design this board, this is what we would do.
Correct. And to even kind of take it to a little bit larger level, it doesn't necessarily even get executed on their own, let's say, reference boards, because this is designed on the highest level by their engineering team.
Okay.
So they're guidance steps, but of course, depending on the vendor's cost considerations, they might not always be executed upon, or there might be a different alternative to reach a similar performance metric.
Okay.
So what this T-topology trace layout is focused at is actually for the next generation of Intel CPU architecture.
Okay.
That will support even faster memory speeds. But with this generation, because we've seen the potential to have very, very high clock speeds. Like, for instance, here we've got,
very high clock speeds on the memory interface.
Correct. Yeah, we've got a 4x4 kit, right? This is a G-Skill Trident kit, 2800. Right, so really high clock speeds and multiple DIMMs, and we've realized that we can even go higher than that. But with the previous daisy chain topology trace layout, we realized that sometimes that could be a limiting factor.
So explain that for a second, right? Mm-hmm. So, and just to clarify, so this is a change to the Ivy Bridge memory controller that comes with a design guideline that Intel recommends you follow.
Exactly. So it should be that the board has to also work in conjunction with the updated IMC.
Okay.
So the CPU in itself is going to, of course, enable those memory dividers and that frequency potential,
mm-hmm.
but on the same level, to be able to meet that, the board should be tuned to this degree.
So what's different in the way memory accesses work now?
Well, the biggest change is actually going to be, let's say, the length of the trace layout. In a daisy chain layout, it's not actually going to be an equal distance from, let's say, the CPU and then the banks of memory themselves.
Okay.
Under the T-topology layout, the actual trace itself, in terms of being linked out, will actually be like a T. So you'll have it go out, there's a T here, and then, let's say, one DIMM, another DIMM. There's an equal distance.
Okay.
In actually the daisy chain configuration, that's not the case. It essentially would go out, then let's say you would meet one DIMM, mm-hmm. right? And then it would trace layout and then be all the way over here for the other DIMM.
Okay.
And that impacts, there's reflection issues, some more complex elements that we're definitely going to detail out to the community through some additional schematics and information to help that understand that.
Okay. And this is fundamentally just trace length matching, right? But on the memory controller side.
Correct, yes.
And this was always one of the concerns about parallel memory interfaces and what Rambus and a lot of the serial technologies were trying to push early on, that, hey, you don't need to worry about this if you move to serial interfaces. Mm-hmm. But there were major cost concerns with that. So there's always been kind of this desire to stick with parallel memory interfaces as long as possible, simply because that's what everyone makes, and you don't have to get over that cost hurdle of going to a new serial.
And technically for this generation, we didn't have to incorporate it. You could definitely still get very good performance, mm-hmm. as we've shown on even like our X79 boards, right, where you've got even more complicated memory architecture, right, and even higher densities, which add a lot of variables.
Yeah.
But more so, we just kind of want to put this in play, give the best performance potential, and be ready for the next generation.
So how does this manifest, right? So you've got, if you have, and presumably this doesn't apply if you put in a Sandy Bridge in this board.
Yes, to a relative degree, right, because it's going to be best optimized for the Ivy Bridge architecture moving forward.
Gotcha. So if you have a memory controller that's kind of aware of this, that it's got, you've got equidistant traces for all of your banks and all of your channels, which you have with Ivy Bridge, what does that get you?
Ultimately, the highest level of the benefit is going to be relative to frequency.
Okay.
It's not going to be an effector of, let's say, latency or other performance characteristics. It's going to be more so that it's going to help give you that highest level of scaling potential.
Okay.
And that's really more so on the upper end of the spectrum.
So this brings up a couple of questions. One, what is the max DRAM frequency that you guys see internally? Mm-hmm. And then what does this give you above and beyond that?
I think that for our, that's a tricky question, because for us, we always spend a lot of time to be better than our competitors in terms of tuning, right? But relative to that, we've internally, consistently, even going down to our standard board, been able to achieve 4 DIMM 2800 speeds.
Okay.
So I think that's an achievement to even say in the value segment, we're getting that level of performance. Where I think characteristically for Ivy Bridge, it's much closer to being 2133 to 2400 target parameters. So we're a little bit over that envelope. In terms of where we've been able to push now is over 3000.
Okay. And you believe that that is as a result of your T topology?
Correct.
Okay. Gotcha. And kind of along the same lines, you know, we had one question come in that was basically like asking how memory recommendations change with Ivy Bridge. You know, what's the sweet spot from your perspective for capacity, frequency, and even installation configuration, right? With T-top, is it better to go for, you know, populate all 4 banks, or is it better to stick with 2?
That's an interesting topic, because with T topology, generally it was tuned to a certain configuration, but we've done kind of other work within the Uefi tuning and still some adjustment to the trace layout to try to balance it regardless of the DIMM configuration, whether you're fully populated or whether you're only running 2 DIMMs.
So you should be able to get similar frequencies regardless.
Correct, yes.
Okay.
And I think that more so we're really stressing the fact that you can get outstanding scaling on even full population and high density.
And traditionally that has been a limitation.
Correct, yeah. Usually if you went, you know, 4 gig DIMMs, right, or you went 8 gig DIMMs, you weren't scaling.
Yeah.
So I think in terms though of the sweet spot, it still continues to really be DDR3 1600 4 gigabyte DIMMs. I think cost relative to bandwidth to performance, all those factors, that's still really where it lies in. I think that being noted, you're going to continue to see more 4 gigabyte DIMMs at 2133 that are going to be a sweet spot. Now, what can be the ready benefit as to why you might want to transition to that? There's going to be a couple of things. One, we've seen some interesting ways that the driver system works within the Intel USB3 ports.
Yeah, you were mentioning this to me in a separate conversation earlier. So explain that. You guys are seeing USB 3 like peak sequential read speeds increase with memory frequency.
With higher memory frequency. So if let's say you were running a default 1333 or 1600 and you switched over to let's say 2133, 2400, even like this 2800 kit, we saw a sizable increase in that sequential based performance.
And this is for like a USB 3 SSD or something attached?
Of course. So the mechanical hard drive, you're already hitting a wall, so that's not going to be the case. So you need some high performance storage devices, you know, or even rated storage configurations that are going to be able to showcase that. But it is available to you there. And of course, then there's other options like, you know, RAM disks or RAM caches.
And so why is that though, right? Like, I mean, if you're typically in that kind of a scenario, you're going to be IO bound to begin with, right? Why would memory frequency at all impact that?
Part of it is it's tied into the driver implementation. So Intel, of course, they don't want to fully release all that information, but they've done some really cool engineering on that driver level to have some cache that's tied into kind of some of the memory subsystem.
Interesting.
So as such, that plays off the memory speed, so you can get an increase in performance. So, as you know,
so perhaps it's like aggressively prefetching data into DRAM,
and the faster the DRAM, then therefore you get a little bit better performance.
Okay, that leads us into a next group of questions, which is really about USB3 Boost. We talked about it a little earlier, but people really want to know: look, is there a matrix of what available, you know, hardware there is out there, what configurations, what operating modes? You know, can you give any more detail on USB3 Boost and what you've seen internally?
So it works from a couple of different perspectives. Right? If we just go the lowest level, all USB ports work on different bus protocols. So we've got the lowest level, and the one that's been around the longest is BOT protocol.
Okay.
And that's what this is all essentially based off. If you just even install our motherboard but don't install our software package, everything's going to work BOT.
Okay.
But with USB 3, we want to take advantage more of the bandwidth because we don't have support for queue structures. We might read and write multiple commands at one time to get effective use of the bandwidth, right? So what we can do is we can transition that into SCSI mode, which is coined as turbo mode. Now this will work for any USB 3 device that gets attached, regardless of the enclosure type, the controller that's inside there.
And what does SCSI mode get you? Just the ability to queue IOs, or
you don't really get queuing. You get a little bit better, optimization in terms of the bandwidth, in terms of the way that the files actually are getting transferred over. So it gives you a little bit better peak bandwidth, and you get reduced latency. Otherwise, outside of that, there's not a huge change. It's really within UASP, which is the next generation protocol, that gives you a big bump up. Now, there are some considerations. Our add-in controller, such as the AS Media Controller chip, that on a firmware level and on a driver level is signed to support UASP. But to get UASP performance, take for instance, you have to have a enclosure that
Yeah.
also supports UASP.
Now, you mentioned your AS Media controller, but I'm assuming the Intel controller as well.
Yes, but not currently.
Okay.
With the Windows 7 operating system, while the hardware does support UASP, you can't unlock UASP performance as of yet. They're planning to
With
roll
the
out,
Intel controller.
Correct.
Okay.
They are planning to roll out full UASP support, but underneath Windows 8.
Okay.
Now, we can extend the performance, though, for the Intel controller from that bot operation mode into the SCSI operation mode.
Okay.
So we can still give you better performance on either controller.
Okay.
But
so you were saying you need a device
it's
that works.
device compliant. So
Okay.
Essentially, just depending on your device, if you're using any standard enclosure that doesn't have UASP support, then it would work in that turbo mode.
Okay.
And then if you have something that's UASP compliant like this enclosure, you can connect that, and then you could go ahead and get that maximum performance.
Okay.
And depending on your workload,
so if I'm doing just like a sequential read, sequential write,
Yeah.
something to an SSD,
Yeah.
you know, what are the graduations of performance that I should expect?
So it depends depending on the controller interconnect. So take for instance, like with this setup right here, if we were to connect this to Intel and we run into bot mode,
Yeah.
you're looking at a little bit over about 300 megabytes read, 300 megabytes write.
Okay.
Not bad, definitely very good performance, right? But if we switch into turbo mode, we could be over 400 megabytes for both the read and write performance.
Okay. And in UASP?
And UASP, we'd see similar, it's a little bit lower than that because,
Yeah.
of course, the link for bandwidth is better on the PCH, right?
Okay.
But we're going to have significantly better Q depth performance. So depending on your workload,
So with more IOs, we do better off.
you could be double the performance of the Intel controller.
Okay. So real quick, you know, I know you guys asked a lot of questions. ASUS, myself, we're all going to be in the comments, you know, answering things where we can. I want to touch on overclocking as kind of the final message here.
Definitely.
Explain to these guys, you know, you guys have obviously tested far more variations of IV CPUs than we have. What are you seeing in terms of overclocking trends? And two, a big question is, you know, do you have to buy the $300 motherboard to get the same overclocking potential that you do with the $200 board? You know, from just quickly speak on that if you can.
One quick answer to that is no. We've spent a huge amount of time on the VRM stage, Uefi tuning stage, that everything essentially down to even our standard level board is going to overclock with similar clock scaling as even our top end boards.
Okay, so even like your mini ITX board.
Yep.
You're good to go.
Standard board, mini ITX board, 4.8 gigahertz, just like our deluxe board.
Okay.
Difference is going to be like on ROG boards, we're going to have more tuning parameters, be able to get into more minutia to make more efficiency, or be able to ratchet up and even get better memory performance. Now, one thing that users should be aware of that's very different for this platform is voltage.
Okay.
So we just want to call that out. Is it really you want to scale back? Keep in mind this is a new architecture, it's a new lithography, different type of TDP characteristic. So
and the other thing to keep in mind is that, you know, IV really is the sweet spot for IV is in the mobile side. So these are going to be tuned for a lower current and lower TDPs in general.
100% right. So we're seeing 4.8 gigahertz is really the realistic scaling frequency that we're seeing relative to air, even on the enthusiast segment, with voltages being closer to about 1.35 on the peak side.
Wonderful. Anyways, thank you guys for sending in your questions, and thank you guys for bringing everything here. We will have giveaways, so check on the site for all of that. And again, thanks again for everything.
Thank you.